Hey, hello ib3 students, welcome my next video lesson about the moment of inertia. Let's start with your homework. You had to find the acceleration of this of system of two masses connected by string by the pulley, but with no moment of inertia, by using second Newton's law of motion. Yesterday we solved this problem by using different methods. We've used the law of conservation of energy. I presented the method how to solve this. Your homework was to find acceleration of this without using moment of inertia, and of course the hint was that you knew the correct answer. Okay, the answer should be the same as one by using different method. Okay, so in this case the idea is to use forces acting on this system separately on mass number 1 and mass number 2. We know that mass number 1 is heavier than mass number 2, so system will be accelerating in the direction presented here. So let's focus on forces acting on mass m1. M1 experiences two forces. Gravitational force acting down, Fg1, and tension, I'm going to use Ft, of the string acting up. Tension of the string is shorter than gravitational force acting down because system is accelerating counterclockwise, so mass 1 goes down. Okay, so overall force acting on mass m1 will be directed down. Let's name it F1. Okay, so we can create exactly the same diagram for mass m2. Mass m2 experiences also two forces, tension, which is the same in this case as tension acting on mass m1, because this is the same string, and gravitational force acting on mass m2, which must be shorter than tension. Why? Because mass m2 moves up. Overall force acting on mass m2, let's name it F2, is directed up. So based on these two objects and these two force diagrams, you can solve the problem of acceleration. So first write equations for mass m1. m1, in the case of m1, we know that force 1 is a difference between gravitational force acting on this mass and tension. I'm talking about this force diagram. Okay, and of course, force F1 by using second Newton's law of motion is m1 times acceleration, gravitational force is m1 times g, and tension is unknown. We can write exactly the same, by using the same method, we can write a equation which links all forces acting on mass m2. Okay, here we know that F2, overall force acting on mass m2, is directed up and is a difference between tension and gravitational force acting down. Of course, by using second Newton's law of motion, F2 is m2 times a, Ft is a tension, and Fg2 is m2 times g. So we have two equations, equation number 1 and equation number 2, and two unknowns, acceleration and tension. So we can solve these equations simultaneously. So first equation, m1a is equal m1g minus ft, and second equation, m2a is equal mft minus m2 times g. Okay, first equation, ft is equal to m1g minus m1a, substitute to the second, obtaining final equation m2a is equal to m1g minus m1a minus m2g. We have one equation, one unknown, so m2a plus m1a is equal m1g minus m2g. Substitute data, so we have 2a plus 5a is equal to 5 times 10 minus 2 times 10, so 7a is equal to 30 divided by 7 A is equal 30 divided by 7. Oh, my calculator, it was probably 4.3, yes? So 30 divided by run matrix, yes, 30 divided by 7 is 4.3 meters per second squared. Okay, so here you have solution. You see that result is exactly the same. Okay, now we will solve the same problem with moment of inertia. I hope that mass of the pulley was 10 kilograms. I hope, because I don't remember. Probably 10 kilograms. Okay, so now your task is to do exactly the same by using forces. Yes, by using forces acting on the objects, and by using mass of the pulley as 10 kilograms, you have to solve the same with moment of inertia. So now the problem is, we have two masses, M1 and M2, okay, connected by string. But now we have additional feature here. We know that pulley has a mass of 10 kilograms, and a force is needed to spin it, because when mass 1 goes down and mass 2 goes up, the pulley starts to rotate. M1 was 5 kilograms, M2 was 2 kilograms, G was 10 meters per second squared. As you know, the radius of the pulley is not necessary, it will be crossed somewhere. And you need also the moment of inertia of the disk, half of mr squared. You know that system is accelerating towards the bigger mass, so acceleration of the pulley is counterclockwise, and your task is to find this acceleration, okay, by using forces acting on the objects. Please copy this. Please try to solve it by doing the same I did on the previous slide, but remember that in this case you have to use also an impact of the pulley which takes energy. Don't calculate this by using law of conservation of energy, but second Newton's law of motion, and eventually torque. Yes, torque will be important here. Okay, so please copy this, stop video for, it's challenging, so for, let's say, half an hour, yes, half an hour, and try to solve it. Okay, so in 30 minutes I'm going to present solution. Yes, so you have 30 minutes to do this. Okay, 30 minutes later. Let's look. Here we have a little bit different situation than previously, because tension of the string, the left part, the part when M1 is connected, is not exactly the same as tension of the string on the right part. Okay, because pulley is rotating. So let's look. Let's draw forces acting on M1. M1 experiences Fg1 and tension, let's name it Ft1. Of course, Fg1 is bigger than Ft1 because overall force must be directed down. Let's name this overall force F1. Okay, let's do the same with M2. M2 also experiences two forces. One of these two is tension 2, which is not the same as tension 1. This is very, very important. Tension 2 is not the same as tension 1 because pulley is rotating. Yes, the string doesn't slide on this pulley. The string is moving with the pulley, which takes some energy from the system. So tension of the string in the left part is not the same as tension of the string on the second part. Of course, M2 experiences gravitational force. This Fg2 is less than Ft2 because overall force F2 acting on mass M2 must be directed up. Okay, so this is very, very important that ft1 is not the same as ft2. Okay, at this moment we can write exactly the same equations. Equation for first, f1, which is equal to fg1 minus ft1, or in other form, m1 times a is equal to m1 times g minus ft1. And for second mass, f2 is ft2 minus fg2, or in little bit other form, m2a is equal to ft2 minus m2 times g. Okay, in these two equations we have unfortunately three unknowns. First unknown is acceleration. Second unknown is tension 1, and third unknown is tension 2. So we cannot solve this system, these two equations simultaneously, because we have too many unknowns. So we need one more equation linking ft1 and ft2. One more equation linking ft1, ft2, and probably acceleration. Okay? So I'm going to create third equation. Third equation will be related with pulley, with this disk. Okay, let's look. This disk experiences two forces. ft1, which is connected here, okay, and also ft2. Which one is longer? ft1 must be longer because overall torque acting on the pulley moves it counterclockwise, rotates it and counterclockwise. So sorry, because here I told you ft1 and I wrote ft2. Of course, on the left part is ft1 and the right part ft2. Okay, the pulley is rotating with acceleration counterclockwise. Okay, and it experiences a torque which is directed counterclockwise. So the torque, okay, acting on the pulley is torque created by force ft1, so I'm going to use f1, minus torque which is created by force f2. I'm going to name it torque 2. Okay, so now how can we write it in different form? That overall torque is equal to ft1, which is at distance of r. Okay, here we have radius, which makes 90 degrees to the force, so moment can be calculated as product of force and this radius. Okay, minus torque, which acts counterclockwise, so ft2, which is at distance of r, because we have exactly the same situation. R is here and right angle is here. Oh, I can leave it if you want. Okay, so total torque is given by this equation. Okay, but what is a torque? In one hand, we know that torque is the product of force times distance, where this force is applied, times sine of the angle between the direction of force and this line connecting the point where force is applied and the pivot. And then other side, you can write torque by using second Newton's law of motion. Second Newton's law of motion for rotating system means the equivalent of force is a torque, equivalent of mass is moment of inertia, and equivalent of acceleration is a circular acceleration, is angular, not circular, angular acceleration. Okay, so what is what here? I is the moment of inertia of this disk, so half of mass times squared radius. And I hope that you know, that you remember that this acceleration, this angular acceleration, can be written by typical linear acceleration by using a similar equation that links velocity, angular velocity, with linear velocity. Linear velocity is angular velocity times radius, and in the same way you can write acceleration. acceleration, linear acceleration, is angular acceleration times radius. So angular acceleration is given by acceleration divided by radius. Okay, so let's create one equation by using these three. This, which is underlined, and these two with stars. Okay, so torque is equal to moment of inertia, so half times mass of the disk times its radius squared, times angular acceleration, which is given by acceleration divided by radius. You can cross radius once, obtaining equation half of m, mass of the disk, times r, radius of the disk, times its linear acceleration of the point which is on the edge. Why is this point important? Because each point on the edge of the disk accelerates linearly with the same acceleration as acceleration of mass m1 and acceleration of mass m2. Okay? And now let's use this equation, the last one, with this one for torque. Yes? So I'm going... Oh, what did I do? Where is my file? I hope I have somewhere this. Oof, yes, I have. So let's connect this one with this one. Okay? So we have half of mass, radius, acceleration is equal tension 1 times r minus tension 2 times r. Okay, so left hand is this and right hand is this. Is it clear? Okay, and this is not yet, but we are very, very close to the third equation. You can cross radius of the disk, is not necessary, and we have third equation to our system. Half of mass of the disk times its linear acceleration of the point on the edge is difference between tension 1 and tension 2. Okay, so now we have three equations. I'm going to use blue. Equation number 1 for mass number 1, equation number 2 for mass number 2, and equation number 3 for disk. Okay, I'm going to rewrite these three equations. M1A is equal to M1G minus FT1. Second, M2A is equal to FT2 minus M2G. And third, half of MA is equal to FT1 minus FT2. And you have three simultaneous equations with three unknowns. Acceleration, tension 1 and tension 2. Okay, so I don't know, maybe let's take tension 1 from first and tension 2 from the second and substitute to equation number 3. Then you will obtain one equation with one unknown. So FT1 by using first equation is M1G minus M1A, and second equation FT2. FT2 is M2A plus M2G, and use FT1 and FT2 put to third equation. So third equation looks half of huge M times A is equal to FT1, so M1G minus M1A minus FT2, so minus M2A minus M2G, minus and plus gives minus. So we have one equation with one unknown. Substitute data. Half of 10 times A is equal, M1 is 5. 5 times 10 minus 5 times A minus M2 is 2. 2 times A minus 2 times 10. Okay, next line we have 5A is equal to 50 minus 5A minus 2A minus 20. Okay, so all A to the left we have 12A, rest to the right we have 30 divided by 12. 30 divided by 12 is 2.5 meters per second squared. and this is acceleration of the system now. And I remember that we've obtained the same by using law of conservation of energy. So you see, method better or not, depending because in my opinion this one is a little bit more logical. Maybe not logical, because law of conservation of energy is always logical, but here we have practical method, different method. If you prefer calculations by using forces and Newton's law of motion, use this method. Okay? If you don't get this, please move backward, read it again, listen me again. All is given on this one slide. Please copy to your notebook, check calculations again, and I'm going to give you a homework. You will do whatever you want, or second Newton's law of motion, so method of forces, or law of conservation of energy, solving a little bit different problem. Okay, so let's imagine that you have a horizontal surface. Okay, there is something which can rotate at the end. Okay, we have two masses. Mass m1, which is placed on this surface. There is a string, mass m2, which is able to fall, and this pulley has a mass of m. All masses are given. m1 is, let's take 10 kilograms, m2 let's take 8 kilograms, and m let's take 5 kilograms. Use g as 10 meters per second squared, and watch out, there's one more detail. Here you have friction. Okay, so this is not frictionless surface. You have a friction with friction coefficient of 0.1. Okay, so friction acts between surface and mass m1, and of course system will be accelerating. Okay, so this disk will be rotating, m2 will be falling, m1 will be sliding on the surface with the friction. We know all masses, gravitational acceleration and friction coefficient, and your task is to find acceleration of the system by using method or law of conservation of energy, something we did previously, or forces, something I've presented during this lesson. Okay, so remember, learn physics, solve this, and see you next time. Bye.